I'm Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I'm going to discuss about the topic superposition theorem for the unit network theorem and source transformation for the core subject circuit analysis and devices, which will be taught for first year second semester. Superposition theorem: in any linear network and bilateral network, a circuit having multiple independent sources, the response of the element will be equal to the algebraic sum of the response of that element by considering one individual sources at a time. Guidelines to keep in mind while using the superposition theorem: when you sum the individual contribution of each sources, we should be careful while assigning the signs to the quantities of the sources. It is suggested to assign the reference direction to each unknown quantity. If the contribution from the source has the same direction as a reference direction, it has a positive sign in the sum. If it is having the opposite direction, then the negative sign will be taken. All the components must be linear to use the superposition theorem with circuit current voltages. It should be noted that the superposition theorem does not involve for the power calculation, as power is not the linear quantity. How to apply the superposition theorem? The first step is to select one among the multiple sources present in the bilateral network. Among the various sources in the circuit, any one of the sources can be considered first. Except for the selected source, all the sources must be replaced by their internal impedance. Using the network simplification approach, evaluate the current flowing through or the voltage drop across the particular element in the network. The same considering the single sources repeated for all other sources in the circuit. Upon obtaining the respective responses for the individual sources, a summation of all the responses will be calculated to get the overall voltage drop through the circuit element. Superposition theorem can be illustrated with the help of some example. In the circuit given below, find the current flowing through the 20 ohm resistor using the superposition theorem. The voltage source is given 5 ohm and 10 ohm current is 10 ohm resistor, 10 ohm and 20 ohm, and one current source will be given. The current source in parallel with the 20 ohm resistor will be replaced by using the voltage source in series. First, let us find the current flowing through the circuit by considering only 20 volt voltage source. Then the current source can be open circuited. Hence, the modified circuit will be shown in figure: 20 volt, 5 ohm, 10 ohm, 10 ohm and 20 ohm. The nodal voltage V1 can be determined by using nodal analysis method. The node equation at node 1 is written as V1 by 20, V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20, which is equal to 0. Then upon calculation, we can obtain the V1, which is equal to 12 volt. The current flowing through the 20 ohm resistor can be found by using the following equation: I1, which is equal to V1 by R. R value will be 10 plus 20. Then I1 can be calculated by using I1, which is equal to 0.4 ampere. Therefore, the current flowing through the 20 ohm resistor due to 20 volt will be 0.4 ampere. Then step 3. Now let us find out the current flowing through 20 ohm resistor considering only 4 ampere current. We eliminate the 20 volt voltage source by short circuiting it. Then modifying the circuit shown in figure: 5 ohm, 10 ohm, 10 ohm and then 20 ohm, then 4 ampere of current sources connected. In the above circuit, the resistor 5 and 10 are parallel to each other, and this parallel combination of resistor in series with 10 ohm resistor. Therefore, the equivalent circuit will be 5 into 10 by 5 plus 10, which is equal to 40 by 3 ohm. Now the simplified circuit is shown in figure. The 40 ohm, 40 by 3, then the terminal A and B, and 20 ohm resistor in along with the current source 4 ohm. Then the current flowing through 20 ohm resistor can be determined by using current division principle. The current I2, which is equal to IS total current into R1 divided by R1 plus R2, which is equal to 1.6 ampere of current will be flowing. Step 4, the summation of current I1 and I2 will give the current flowing through the 20 ohm resistor. Mathematically, it is represented as I, which is equal to I1 plus I2, which is equal to 0.4 plus 1.6, which is equal to 2 ampere of current. Therefore, current flowing through the resistor is 2 ampere. The limitations of superposition theorem. The superposition theorem requires only 2 or more sources in the circuit, does not apply to the non-linear circuits. Assessment questions. What are the superposition theorem? Is a superposition theorem is valid for AC circuits? Can the superposition theorem apply to non-linear? No. Is a superposition theorem is applicable to the power? Does not included for power calculation. Why do we use superposition theorem? It is important in circuit analysis because to convert the complex circuit into Norton's or Thevenin equivalent. Thank you.